This is B300. It's GB300 NVL72 versus B300. What's the difference? Well, the clue's in the name. There's no G, there's no Grace. That's the CPU. These are available from Supermicro based on the AMD EPYC platform or the Intel Xeon platform, and that's the compute infrastructure. But you still have the ConnectX-8 backplane, you still have the ConnectX-8 networking, and that also provides the PCIe Gen 6 interconnect for your GPUs. Your GPUs run over this high-speed fabric, and that is all the same, that is all the NVIDIA ecosystem, but some customers don't want to leave x86 behind. They're not ready to experiment with Grace or ARM-based solutions, and so this gives you the NVIDIA GPU fabric, this gives you the build-out, but with a familiar x86 platform. This is the B300 from Supermicro and NVIDIA. It's a building block for your data center. It's Supercompute 2025. I'm here with Supermicro. Phil, you know all the things. You know where all the bodies are buried. You've had all the customer experiences.
Yes.
What's the biggest difference? It's been a year. Can you believe it's been a year?
Can't believe it's been a year already. Time really flies. Yeah.
How's that yearly product cadence treating you?
It's interesting. It keeps us busy, that's for sure. Yeah. I think that in terms of the launches this year, there's definitely some interesting happenings, especially with networking. We're seeing that transition from 400G to 800G for the compute fabric. So you'll see that present in some of the AI optimized solutions that we have.
So
here.
800 gigabit per fiber optic link, and you guys are just casually shipping that to customers in volume.
We're starting to. With the NVIDIA Blackwell architecture platform, we're in that stage of going from that transition from the B200 generation to the B300 generation. So you'll see that integration of the ConnectX-8 NICs onto the GPU baseboard to bypass the limitations of the PCIe bus.
Yeah.
So
that's
one of the things that comes to mind, I guess.
Yeah, that's one of the things you guys are showing here at the show. Yeah. So with ConnectX, the networking and the PCIe fabric have sort of merged together. That is actually running at PCIe Gen 6. We first saw a little preview of that at Computex 2025, but it's shipping in volume. It's part of the Blackwell experience, let's call it.
Yeah, we have some of their systems over there that feature the you can see it from those 8 OSFP plugs that come out of the top of the system. And then also with some of the racks that we have on display. So this is the first time that we're showing an HGX B300 based rack. And we have that with our direct liquid cooling on display in our booth.
So this is full rack scale, like you're shipping fully assembled, configured racks ready to go as a kind of data center building block, and it makes it easier for customers to integrate. It makes it easier to deal with that yearly product cadence.
Yes, it does. Being able to have a fully integrated solution that's like ready to deploy is really kind of been a major focus.
It's like, where do you unplug the racks and plug them in?
And we're trying to like incorporate more and more components of like, an overall bill of materials that's required when you outfit these data centers.
Well, the other thing I've noticed with in 2025, we're kind of at the end of 2025, and the other thing I've noticed is, the AI factory story from NVIDIA. They've got everything from the very small DGX Spark, of course, but you guys are also showing DGX Station.
Yes, we have DGX Station based.
And Blackwell workstations all the way up to like GB300 NVL72.
Yes.
So, start at the small and then walk me through, but it's all the same software ecosystem. Like if it runs on the little, it'll run on the big.
Yeah, that's one trend that we've seen as well, is like local development for consistency with the local development and deployment in a server.
It's like, has that been in terms of like a customer success story or customer deployment story, like how many customers are embracing, because like if you go the full GB300, you got your cooling tower and you got the liquid cooling and like you have the full retro conversion stuff, assuming you can get the electricity.
I think that there's a lot of challenges with deploying AI infrastructure in general. We do try to streamline it with our data center building block solutions and the fact that we're trying to incorporate a lot of services to make it really seamless. That being said, GB300 is a rack scale solution. 72 GPU NVLink domain, by itself is like not something that everybody's going to require. There's even you can even consider something like an HGX based solution as another step down from that, where it incorporates an 8 GPU NVLink domain. And then, scaling beyond that, we'll be going over the compute fabric. So I think it's really about figuring out what you need in terms of your workload, because not everybody requires the max interconnected, 72 GPUs and NVLink. HGX has traditionally been that flexible kind of sweet spot where you can do inference, you can do training, and things like that. But I think that we've seen a lot of enterprise needs kind of starting to shift away from the training side and more towards like actual using, deploying inference and things like that. Production applications, and fine-tuning as well. Yeah.
Hi, I'm Vic Malyala, Senior Vice President for Technology and AI, and have the luxury of working with many, many customers, and I'm super glad to be here talking to you.
Supercompute 2025. The first question I have is, what's changed since 2024? How are you adjusting to that yearly product cadence?
My God, I think it's an exciting time, for sure, right? Because Supermicro, because we are totally vertically integrated, we design, develop, and manufacture everything in-house. So the technology, when it changes quick, we are the first ones to basically make it happen. That's a good thing. But what is even more exciting is the changes that are happening in the industry and how we are able to transform ourselves to make us relevant and be able to bring the right platforms and solutions for the customers. So 24 to 25 is just kind of further accelerated.
Yeah, it's been sort of nuts to be able to watch all the different solutions. I mean, you guys are shipping customers solutions at rack scale, and that shortens the time to market, because when the new products come out every year, you guys have to ship quicker, the customers expect things quicker, they better be able to deploy. These things, you just show up, you plug them in, you give them some liquid cooling, and you're done.
Well, that's what we want it to be. But as the product's getting more and more complex, that's when I think the real, I would say, challenge comes into picture. That's where our engineering forces being, here in Silicon Valley, as a US company, that makes a big difference because we have access to the likes of NVIDIA, AMD, Intel, and all other technology partners that we work with in bringing these technologies, right? So that's one aspect of it. Second is the whole concept of this sovereign clouds and data security and privacy. All these things are coming off in multiple angles. So whether it's in US or in different parts of the world where people actually pay attention to those things, we are actually stepping in and figuring out a way to get them the right solution, whether it's standard compute or the storage or the AI and the whole thing coming together in a data center as a Supermicro data center building block solution. So again, when you ask what changed, super exciting times because of that.
You guys also, as part of your solution, have like the full certification for NVIDIA's AI Factory software part of it. And with the yearly product cadence, that means that there's going to be a lot of mix of generations across physical deployments. But part of the software stack is to try to make that as transparent as possible to developers.
So the good thing is that if you take a look at NVIDIA, we work with NVIDIA on the NVIDIA blueprints for all these things. But the good thing is on the factory side of it, we are the factories that are making factories that run AI, right?
Yeah.
So tokenization is important and people are able to do that at scale, but most importantly, we need to get the right platforms and solutions for that at the right time, and that's where we are. So we're enabling the AI factories.
I like the Supermicro solution planner, where it's like, here's my data center floor plan, here is how much compute I would like, and it's like, great, here's your order list.
There you go.
All the way down to the screw.
Literally, because that's what is needed in order to optimize at every scale.
Yeah. Don't think of NVIDIA's B300 platform as just the Blackwell GPUs in a different box. This is the first generation where NVIDIA has leaned all the way into building the fabric that ties the GPUs together. And that fabric is now faster than anything in the CPU world, faster than anything that current CPUs can approach. Each GPU gets its own native 800 gigabit ConnectX-8 interface. That's not really a lot different, one network interface for one GPU from prior generations. But what is different is the network and the PCIe fabric are all combined together. All 8 GPUs are linked through one fully connected PCIe Gen 6 fabric from one host PCB in our Supermicro chassis here. In previous generations, you had a PCIe bridge chip plus separate ConnectX NICs to build the fabric. Now it's all combined. All of that collapses into a single, tightly integrated interconnect with dramatically better latency and throughput. The network is the fabric is the network, and it moves data at literally double the rate of PCIe Gen 5. So yeah, sure, the backplane that ties into the CPUs, this whole thing connects to the CPUs at PCIe Gen 5 because that's what we have with x86 server chips and basically all CPUs everywhere currently. But the GPUs can signal at twice the rate of PCIe Gen 5, twice the rate of any current x86 CPU, and that's the point of this architecture. Corporate is going to need us to find the differences in this B300, this B300, and that B300. 8 GPUs in these systems. The difference really is just the cooling.
Yeah, so we have an air-cooled B300 system a liquid-cooled B300 system and another liquid-cooled B300 system. So the differences between these, we'll start off with the air-cooled because I think this is one that's easier to deploy. If you remember the B200 system, that was 10U. So as you can see, this is 8U. So what happened?
A little smaller.
Yeah, a little smaller. And part of the reason for that is because actually the GPU tray ends up being the same height as before, because you need that extra space for the thermal headroom for the large, tall heatsink. But on the CPU tray, you can see that this is down to 2U from 4U. So it's no longer 10U, and that's because of the going from 500 watt CPUs down to 350 watt CPUs.
And that's just a change to the EPYC 9005?
Not only the EPYC 9005, like the B200 system, the original one that we launched was utilizing also Xeon 6900 series that was drawing 500 watts. And switching to the 350 watt 6700 series didn't really have any drop in performance for AI applications. So that's one of the reasons why we kind of moved forward with this system in 8U to get that 2U height on the CPU tray, because there's no real performance disadvantages from doing that for most of the AI applications that are being ran.
Many customers want the B300 over the GB300 precisely because it's x86. It snaps directly into the operational universe enterprises already run. The same monitoring agents, cluster schedulers, PXE netboot customer workload provisioning toolchains, BIOS automation, redfish management, kernel drivers, security policies, container runtimes, VM provisioning workflows. Nothing has to be reinvented under any of those banners, and that's what I've personally seen in the data center. And critically, choosing x86 not in any way hobbles the Blackwell architecture, all thanks to that PCIe Gen 6 GPU fabric. The NVLink bandwidth, the 800 gig ConnectX-8 networking, all of that bypasses the CPU entirely. The CPU is no longer the system bus driver, pun intended. It is just the bookkeeper, the control plane, and maybe the data fabric manager, depending on how you're plugging this into your architecture. I noticed this thing has six kilowatt power supplies, though.
Yeah. So
that seems like a lot.
6 kilowatt. Yeah. So we have it's got a tremendous amount of power delivery. The HGX B300 GPUs do pull a little bit more wattage than the B200s at about 1,100 watts, and with 350 watts per each CPU, you got plenty of headroom to spare, I guess you could say.
So in the universe of NVIDIA solutions for AI, this one kind of sits in the middle, right? We have 8 GPUs, and you get the full fabric, and it's ConnectX-8.
Yes.
That's also another PCIe Gen 6 situation. We have 8 ConnectX-8, but it's 1 per GPU, 1 kilowatt for the GPUs, and then you've also got dual Bluefield.
Yeah. So I guess, like you said, if you're saying that it's in the middle of like the NVIDIA overall, tier list, you could say is like, it's definitely on the higher end. But if you're comparing it to something like GB300 NVL72, then for that solution you would have 72 GPUs connected at 1.8 terabytes per second each, whereas you have 8 GPUs connected at 1.8 terabytes per second each. Beyond that, scaling beyond that, previously you would have to go over PCIe 5.0 via ConnectX-7 NICs. Traditionally, 8 of those would go in front here in the single slot PCIe 5 slots, but with B300 generation, the ConnectX-8 NICs are integrated into the GPU baseboard to provide up to 800G connectivity.
So at the same time, this is the absolute pinnacle of performance that you can get with air cooling.
Yes, that essentially is true, because solutions like the NVIDIA GB300 NVL72 are only with direct liquid cooling. Now we are showing our sidecar CDU that can convert a liquid cooled solution like that into air cooling up to, I believe, 200 kilowatts. But that being said, I think for all intents and purposes, this is pretty much the highest performance that you're going to get for AI applications on air cooling.
But you've also got, if somebody did want to experiment with liquid cooling, they can have the same exact, the developer doesn't know. The developer that's running their their workload, whether it's on this system or this system, they don't really know. And so that gives the physical infrastructure and data center people an option to get their toe in the water, because the next generation after this, they're going to have to be familiar with liquid cooling. They're going to have it.
Absolutely.
And this gives your customers a path to go from, it's like, okay, we're comfortable with air, we're going to bet the farm on air this generation, but we'll pick up a bunch of nodes that are on liquid cooling and start down that path.
Yeah, so I think that this particular system, this is on 2 open rack units, so 2 OU, whereas we have the 4U liquid cooled system that's designed for standard 19-inch width racks.
So this is more open compute, and this is more your standard 19-inch rack.
This is an open compute project rack format, so 21-inch width, and it's also with a bus bar style design, so kind of like the GB200 and GB300 NVL72. It kind of slots in and uses externally mounted power shelves. So 2U, it's great. And then you may have, I believe, a 1U for the power shelf, so it's 3U instead of, say, 4U. So this is really the densest possible type of B300 system that you can deploy. So it's targeting use cases like for hyperscalers who are trying to build the densest possible AI clusters.
Nice. It's also nice for integrators that are not necessarily ready to step into. It's like, we're ordering the cooling tower, we're ripping everything else, we're going to be all liquid tomorrow. This is kind of a nice transition sort of a deal.
Well, the idea is that we try to have the different options depending on the customer's needs. So 4U, that's for setups with, say, a 48U rack with 8 of these system nodes, and then an in-rack CDU, that's 4U. We've moved a lot of the I/O to the front of the system. So as you can see, you got the networking ports here, DPU active connections here, and that's to ensure that liquid cooling is on one side. And then on the cold aisle, you can access like all the connections that you may need to configure from time to time.
64 GPUs per rack.
64 GPUs and a 48U rack. Yes.
That is kind of nuts.
Yeah, it's kind of nuts. In terms of performance density, it's pretty much as high as you're going to get, except for solutions like GB200, GB300, NVL72 that has 72 B200, B300 GPUs in a rack. Beyond 8 system nodes in a rack, sometimes it's not preferred. Like technically, we could throw another few system nodes into a 48U, but from a network topology standpoint, it doesn't always make sense.
Yeah, that makes sense.
Yeah.
And it's nice to see different configurations and different options.
Yep.
And it's also sort of fun that it's like, yeah, we want something that's even higher end. It's like, well, your only option is going to be GB300 NVL72. Like that's, you're going to go. What do you think customers, like what's the customer experience like? Is GB300 NVL72 more turnkey, and this is for more DIY customers that want to customize it, or is it just depend?
They both end up being somewhat turnkey, I would say, because we're typically deploying solutions like these into like larger scale clusters generally for AI training with integrated racks, power cooling, and things like that, all in one package to make it as plug and play of a deployment experience as possible. Basically, people are not, it doesn't really make so much sense to deploy a single one of these systems when they are designed as a scalable building block.
Well, you've got all those interfaces, what are they going to go to?
Exactly, so it's got to take advantage of things like a Quantum X800 InfiniBand switch and things like that.
Well, if you only need one or two, you guys have your RTX Pro 6000 rack workstations, which we'll take a look at in just a minute. But yeah, this is more for scale, because you want the fabric. The fabric is where the magic is. The fabric is literally PCIe 6.
Yeah, it is. Yeah.
The GPUs talk amongst themselves, and it's a faster interconnect to the other chassis than it is from the GPU to the CPU. That's kind of nuts.
Yeah.
And then you've got Bluefield for all of your offloaded storage. Now Vic was talking to us about this earlier. He said the storage story was really interesting in 2025 over 2024, because Bluefield and automate. Like Bluefield it's a GPU on a network card basically, but that lets you offload processing, and so it's nice to see. It's like, oh yeah, we rolled that in.
Yeah, we have like some storage systems that are on display that don't have CPU anymore. So it's only used for GPU direct storage. So it's only loading data directly from the drive directly into GPU memory, and that's all it's used for. Because and even in the cases of traditional storage systems like our flash-based storage systems, it still fully supports GPU direct storage, and also as well as a variety of our software-defined storage solution partners that we came up with.
Yeah, we've heard Jensen talk a lot about improvements and changes to the way that scatter gather happens and the way that a lot of those workloads run, but that has implications not just for inferencing, but also training and scaling and everything like that. It's nice to see that the solution is adaptable enough to rise to those challenges.
Yeah, there's a lot of different I/O patterns when it comes to these AI workloads, and also there's lots of different needs in terms of archiving and storing. And so you need the data lake tier, which is traditionally handled by some spinning disks.
Yeah.
And
that doesn't have to be quite as fast as the 800 gig to 1.6 terabit, but
exactly.
It's still absurdly fast.
But in terms of the application tier, it's usually flash-based systems, NVMe drives in terms of drives themselves, loaded into the GPU memory via BlueField 3 GPUs.
At a low level, like what's happening there, it's the GPU basically calls for direct NVMe storage using the NVMe protocol over this fabric that really doesn't look a lot different than PCIe. Is that how you would describe it, or like at a low level, it's really just the GPU accessing the storage directly?
Essentially, yes, yeah. But I'm not the expert on that. The protocols, the NVMe and PCIe, things like that. So you'll have to talk to some more networking or storage experts here to speak more towards that.
We have to feed the GPUs faster and with lower latency, and this is how we get it done.
Yes, exactly.
So B300 Air, this is the fastest air-cooled system on the planet, period, right now. And then you can get your toe in the water with liquid cooling, or switching over from your 19-inch rack to the OCP standard. That's fine, 21-inch rack, or stick with your 19-inch racks. Don't sleep on another big feature of B300 here, and that is you can do an air-cooled configuration. 8U, 10U in the configuration that we're looking at here gives you plenty of PCIe expansion. It gives you options for that air-cooled data center. If you're transitioning from air to liquid, there are also options for that. And if you're an open compute style rack, or the open compute specification for racks, they're a little wider, get this in a 2U open compute rack configuration as well. But that's going to be liquid cooled. You can add the sidecar, get it done, but it's going to be liquid cooled in that config. So this is we're dealing with a 19-inch, standard 19-inch rack. This isn't open compute, but this is a, more or less standard liquid cooled configuration. We got our CDU at the bottom. You can deploy this if you're getting your toe in the water with liquid cooling, but this is all B300, so 8 GPUs, and then you've got your ConnectX 8 networking.
Indeed, 8 GX B300, 8 GPUs, either with Intel or AMD CPUs. Front I/O, as you can see, the 8 ConnectX 8, 800 gigabit per second. You can have it with 8 systems in a 48U rack. You can have 12 of them in a 52U rack. You can have them with an in-rack CDU or in-row CDU.
There's still a little bit of room here at the top for additional networking, or more networking, or maybe your fiber optic, your old school fiber optic fabric. Although if you took this, would connect to these, I guess, and so you'd have your quantum fabric that way. But
this would be the leaf type of tier.
Yeah, and we don't unofficially speeds. We might guess that that's 1.6 terabit. I don't know.
Something like that.
It's fun times. They have to announce something every show, and Jensen's running out of runway before he gets into Vera Rubin. So quantum networking.
Yeah, this is the moment, guys. Yeah, this is the show for that.
Run AI is NVIDIA's orchestration layer for AI workloads. NVIDIA gives you this to give you a head start for turning your entire GPU cluster into a single shared pool of resources that can be automatically scheduled, sliced, and optimized for any job. It handles queuing, priority, multi-tenant fairness, elastic scaling, and everything like that, so that teams don't have to hand manage or try to DIY a GPU allocation infrastructure or GPU allocation plumbing. In short, Run AI makes big GPU clusters behave like one unified, efficient machine, while giving different teams fair access to the resources that are available. So NVIDIA is very interested in making sure that the developer experience is solid across anything from GB10 to DGX Station, GB200, GB300 NVL72. And as part of that, they want to control the entire ecosystem and experience. And so you guys have delivered the orchestration platform that ensures that the developers will have a consistent experience. So like if they go to NVIDIA.com and they run through some of the tutorials, the inferencing microservices, and it's like, oh, you want to be able to run this locally, it ensures that that walkthrough, the playbook provided by NVIDIA, will give the developers the experience that is on NVIDIA.com.
That's exactly, and we validate it in-house. So for example, Run AI has the developer environment like Jupyter Notebook. Just one click to download, you don't have to do installation. It's right inside the platform, Run AI. You can build your AI LLM workload right through Run AI. After you build your AI workload, you can schedule that job. Have the Run AI, maximize your GPU usage, orchestrate all your jobs, scale up, scale down, and it's all in one single platform.
From the optics to the copper topology, the cooling envelope, the cable routing is locked to the nth degree with deliberate precision. NVIDIA is telling the world, build your infrastructure with these components, and the next generation, Vera Rubin and beyond, becomes a component swap, not a reinvention. That's the main promise when NVIDIA says AI Factory. It's not about buzzwords, it's about standardizing to such an extreme degree that a builder building with these building blocks can focus on what they're building. It's not about the rack, it's about the architecture. It's about building the infrastructure. And that's a hardware and software problem together, tightly knit. From here on out, the entire industry upgrades are componentized, whether it's the silicon doing the compute, or the silicon doing the adaptive routing, the networking, the optics, or even new math kernels on the software side. We've discovered a new way to do floating point efficiently. All of that is meant to be easily swappable into your solution as soon as it's available. And here's the parallel story on the software side that I think so many have missed in NVIDIA's messaging. Don't focus on the physical, tangible aspects of the AI Factory with the GB300 NVL72. Focus on its larger software ecosystem. It's going to far outlive the hardware anyway. NVIDIA has dramatically expanded what it means to be turnkey, far, far above CUDA and NVFP4 math kernels and all of that. This is a gift for implementers. Look closely at Run AI. It's for workload orchestration. It turns the cluster into a single schedulable resource pool so teams don't waste time reinventing cluster management. And what about Omniverse for simulation and digital twin pipelines? That's not just CAD on steroids, it's the bridge between physical systems and the AI models that control them, that enable training and validation and scenario testing in a photorealistic simulation environment down to the individual screws. And Cosmos. Cosmos brings multimodal reasoning and agentic systems into the same standardized workflows, using the exact same building block philosophy as the hardware. Standardization, predictability, easily swappable upgrades, starting to sound more like a factory yet? And as the compute involves, the orchestration layer, the simulation layer, and the multimodal layer, all of that evolves, they can be swapped out like components. This is the role that NVIDIA sees for themselves in every company. They're providing the end-to-end scaffolding, the physical machine and the software that turns AI development from a bespoke craft into a truly industrial process. And so that's why NVIDIA's GB300 NVL72 isn't just a rack, it's a reference design for how token generation is going to happen at scale, probably for the next decade. I'm Wendell, this is Level 1, and this has been a fun, exciting look, I think, at the GB300 NVL72, and boy, it sure is going to be interesting to see where they go from here.